And here we are with the calculations portion of Lab 3. So this is an example of what your data sheet will look like. Make sure you fill it out neatly and submit it on Blackboard, a good clear picture of it. For most of these labs, you're going to be printing out the lab or purchasing the lab manual so you have a book to work from, and then taking a picture and sending it to me, mostly because it's much easier to handwrite math than it is to try to type it into your computer. So I don't want to see you trying to do that in Microsoft Word. It'll take you much longer than it needs to. Okay, so the first problem was, what is the rate that a marble would fall down a tube in terms of miles per hour? The information we got was inches per second. So I'm going to show you how to convert that. So the information we got, we're going to write the rate down, 41.5 inches for every 1.16 seconds. And let's do that division to find out what the rate is if we were to put that over 1, meaning we'll divide that out. So 41.5 inches divided by 1.16, our rate is 35.78 inches per second. Now, how many significant figures should we use? I see 3 here and 3 here, so we can use 3 significant figures. So let's call that 35.8 inches per second. Now, we're looking for miles per hour. So we need to make our famous conversion factor from chapter 2. You've been learning a lot about that. And we'll put seconds on top because eventually those will cancel. And what we're converting to is hours. So for every 1 hour, this is our conversion factor, our equivalent statement. 1 hour equals 3,600 seconds. So when we multiply through, seconds cancel, and you're going to end up with hours in the bottom. That's what we want. And then we're going to convert inches to feet and then to miles. I'm going to take this one step at a time. Some people like to set it up with many parentheses next to each other. If you do that, just make sure that you follow your math very carefully. It's easy to make a mistake if you do it that way. It's okay and it takes up less room, but just be really careful about your math. Okay, so we're going to multiply 35.8 times 3,600. We have 1 on the bottom, so we don't have to divide by anything. So I'm going to take, here's a tip about significant figures. You don't really have to round until the very end, so you can keep this number in your calculator. And we come up with 128,793 inches per hour. Now that's not a very convenient number to use. So we need to convert inches to feet and then feet to miles. So how many inches are in a foot? We put inches on the bottom so that it cancels. For every 1 foot, there's 12 inches. So because we have 12 on the bottom, we take this number, multiply by 1, so you don't have to do anything to it, divide by 12, and we're going to get our measurement in terms of feet per hour. So there's our number, divide by 12, and we have 10,733. Let's just write that number down. Notice I rounded in the ones place. So we have 10,733 feet per hour, and we're looking to get to miles per hour. So now how many, for every 1 mile, there are how many feet? 5,280 feet in a mile. That equivalent statement may have been given to you, yep, here in your lab book, where you can always look it up. So this online class encourages you to definitely use your internet resources. So we can cross out feet. If it's the same on top and bottom, you can cross it out. So now we take our number, multiply by 1, meaning no change, and then divide by 5280 to get our rate. So we're going to take that, divide by 5280, and we get 2.033. Now I'm going to write down that much and then we'll do our rounding. And that's miles per hour. So let's look back here. In our original statement, we have 3 sig figs on the top and the bottom, so in the end we can keep 3. So I'm going to underline 1, 2, 3. Those are the 3 we're going to keep. Remember, the 0 is significant because it's captive. And we're going to look 1 past it. This is below 5, so we keep this 3 the same. So our final answer is 2.03 miles per hour, or you could write it as miles over hours. So that's how fast that little ball was rolling down my inclined plane, 2 miles an hour. Okay, so I expect to see your work neatly shown like that, and make sure you submit that on Blackboard. That's question 1. And really this lab is very helpful to prepare you for the semester and to prepare you for exam 1. We're really going to be using unit conversions a lot, not always feet to miles, but units relating more to chemistry. So for problem number 2, we measured how fast the water flowed out of the sink in terms of liters per second. Or you may do gallons per second if you have a gallon container, which in the US there are plenty of. So, let's see. For the sake of time, let's say you did measure 1 gallon instead of 1 liter. I assume many of you will probably take a milk jug or even a pint container that you can easily convert to gallons, or maybe you have a 5-gallon bucket. So let me show you that, starting with gallons. So let's say that we dispensed 1 gallon in 12.32 seconds. So the first thing we want to do is find out how many gallons per minute that is. So I'm going to take the number and divide to figure out our rate in terms of gallons per second. So that would be 1 divided by 12.32, and our rate is 0.0812. I'm going to write all that down. Gallons per second. So we're dispensing 8/100ths of a gallon every second. So the question's asking how many minutes it would take to dispense 500 gallons. So the first thing we need to do, this is our conversion factor. We're going to write seconds on the top because we see it on the bottom here, and hours on the bottom because that's where we're going. 3,600 seconds are in an hour. This is our equivalence statement, written as 1 hour is equal to 3,600 seconds. And remember, always one side goes to the top and one side goes to the bottom. This is a great lab for practicing that. So seconds cross out, and you just take your number and multiply by 3,600. And we have 292.2 gallons per hour. Actually, I think the question was asking about minutes, wasn't it? We can convert back. That will be even more fun. Okay, so we have gallons per hour. So now they're asking if I want to dispense 500 gallons. Let's write that down. That's our measurement. I want to dispense 500 gallons. And I know that my rate is 292. Let's check our significant figures. We had 1 on the top and 4 on the bottom. So actually, let's keep 1 significant figure. We're going to call this 300 gallons per hour. Okay, so if I know we can dispense 300 gallons per hour, I'm going to make a conversion factor. And where will I put gallons? If it's on top here, I'll put it on the bottom here. And I'm going to write 300 gallons for every 1 hour. Cross out gallons. So it becomes 500 divided by 300, or simply 5 over 3. And 1.6 repeating is how many hours it would take. And to stick to what the question is asking us, they want to know about minutes. So I accidentally converted to hours, no problem. I'm going to go back to minutes. So hours goes on the bottom. Minutes goes on the top. For every 1 hour, we have 60 minutes. Cancel out hours. So we're going to multiply our number by 60 to get 100. What a nice number. So out of my sink, it would take 100 minutes to fill 500 gallons, if we want to fill a 500-gallon tank. Interesting. Okay. And the third part, they were asking us about how long it would take to walk to Ogdensburg. Do you have any guesses? Do you have any guesses about how long that would take to walk about 20 miles? I'm not sure. Let's find out. So, at the pace I walked, which was really a stroll across my kitchen, I was moving 10 feet in 4.75 seconds. That was my rate. So let's put that in terms of feet per second. So I'm going to do 10 divided by 4.75. 2.11, I'm going to write down, feet per second. And this is very similar, actually, to the first problem, where we convert to miles per hour, but then you just have to take it one more step and figure out how long it would take you to get to Ogdensburg. So let's follow the same steps we did up above. Now problem number 3, we're going to do in a linear fashion called dimensional analysis. And we're going to first convert feet to miles. So there are 5,280 feet in a mile, just like we used previously. And then we're going to convert seconds to hours. So there are 3,600 seconds in 1 hour. Notice seconds on top and bottom will cancel. Now this technique, this dimensional analysis technique, takes up less space, but you have to be very careful about your math. So what we do is we multiply everything on the top by one another. That's the first thing. So we're going to do 2.11 times 3,600. And we get 7,596, and the unit that's left is miles. On the bottom we have, if it makes it easier for you, you can always extend this line and draw a 1 so you know for sure. You don't have to multiply by anything. We just have 5,280 on the bottom. And the unit is hours. So we have miles per hour, we just need to reduce that fraction. So 7,596 divided by 5,280. I think I hit the wrong button. Gives us 1.439. Let's write that number down. Notice I'm just taking several numbers and writing it down, and after that I'm going to round to figure out my significant figures. So our rate, we have 10 feet and 4.75. Now this, you'll find in Chapter 2 in some of the example problems in the online textbook. Context will tell you how many significant figures we're talking about. So in this case, technically, because there's no decimal point written, there's one significant figure. But I know that when I measured it, I definitely wasn't. So we were talking about significant figures in our final measurement. I was saying that although there's not a decimal written here, I was sure that I had about 10 feet. I didn't think it was 9, I didn't think it was 11, because I was using a measuring tape that was in terms of inches. So we can assume this to be two significant figures. You see a lot of examples like that in your book. So in the end, 2 and 3, the lowest one is 2 significant figures. We're going to keep 2 in our final measurement. So our rate is 1.4 miles per hour. And we're not quite done yet. They're asking us how long it would take to get to Ogdensburg, which is 19.5 miles away. And I'll use my rate to do that calculation. So I'm going to put 1.4 miles on the bottom and 1 hour on the top. So I'll take 19.5 and divide by 1.4 to get 13.9. So if we keep 2 significant figures, it will take me 14 hours of walking to get to Ogdensburg. And that's a long time. So this is what your data sheet should look similar to. Make sure you're very clear about your units. Always write your units. Always show your calculations carefully. And upload a clear picture onto Blackboard along with pictures or videos of you doing the experiment. And and good luck. Thank you.